Hi, my name is Amanda Bowles, and this is my project on the physics of climate change. Here's the introduction. Climate change has made a big impact on the Earth over the past decades. New research has been conducted to try to understand the changes that are happening. Many of the climate changes have been involved with increasing levels of carbon dioxide and other atmospheric gases in the environment. The changes also include temperatures, precipitation, patterns, and wind currents. The ocean levels have also shown that the change of the climate within the recent years. The sea ice contributes to the rising ocean levels and the animals' homes that it also affects. The sun and the earth. The sun is a big contributing factor of the Earth's global climate changes. The sun is the source of most of the energy that drives the biological and physical processes in the world around us. In oceans and on land, it fuels plant growth that forms the base of the food chain, and in the atmosphere, it warms air, which drives our weather. This is from one of the sources. Over time, the sun distributes energy differently once it passes to another day. So each day, the sun will have a different energy level for each different environment that it's shown over. This causes the surface area of the Earth to have different temperatures throughout the day, and the ocean will change with the temperature as well. So once the Earth has rotated on its axis, this shows the difference between the temperatures of night and day, whereas some places at night will be a little bit hotter and some will be colder. And then the ocean will also change due to its different layering of when light is visible or not. It has been suggested that the changes in the solar output might affect our climate, both directly by changing the rate of solar heating of the Earth and the atmosphere, and indirectly by changing cloud forming processes. The sun's rate of energy is the cause of this. Another factor that the sun causes is the solar intensity of heating up the environment in different intervals. The sun is the main source of light for Earth. It helps produce most of the different colors we have once it is absorbed through the Earth's surface. The greenhouse gases. The other term of effects of climate change are the greenhouse gases in the atmosphere. The surface temperature is made from the heat absorption and emission of the heat radiation. The greenhouse gases from human interactions show the water vapor and carbon dioxide to try to keep the earth warmer than it naturally is supposed to be. These greenhouse gases will keep all of these so much of the stuff inside, like the carbon dioxide, the methane, the nitrous oxide, and it will just speed up Earth's temperature to where everything feels so much harder. And then it will release some of it, but it keeps more in than it will release out. This has caused an increase in the concentrations of the effects. For example, the atmospheric concentration of carbon dioxide has already risen about 30% from its pre-industrial level, and methane concentrations are more than double their pre-industrial value. As you can see, over time, these levels just keep growing and growing until finally they're going to reach astronomical heights where we probably won't have any control over trying to fix them. Here you can see an example of how the greenhouse gases work. You'll have the light from the sun, which goes down into the atmosphere, and about 23 of it is absorbed and it'll reach down to the earth, but more of it will reach towards the surface, and then only about 29% of it's reflected back into space. Then you have where it keeps radiating back and forth, where it's about almost 90% radiated back to the surface. And then you have those long wave radiant energies from the earth back into space. Here's another example just to show a easier, simple way of how they work. So you have your solar radiation powers from the climate system, whereas the sun radiates over into the earth through the atmosphere, and about half of the solar radiation is absorbed by the earth's surface and it warms it. And then most of that's bounced back from the atmosphere or from the earth, and it's reflected back into space. And then you have where some of the infrared radiation passes through the atmosphere, but most is absorbed and readmitted in all directions by the greenhouse gases molecules in clouds. The effect of this is to warm the Earth's surface and the lower atmosphere. So the greenhouse gases almost act as like a barrier from some of the absorption to be released back into space. You have what you would call negative feedback, which is what determines the solar radiance of the climate change that has occurred over the past few decades. An example of a negative feedback would be an increase in clouds that reflected more sunlight back into space. The actual feedback from changes in clouds is uncertain since they also trap outgoing infrared radiation. So like in the graph before, it showed that some of the radiation is also getting caught up in the clouds too, so not all of it's getting released back into the atmosphere, that it's just holding it in. So when precipitation occurs, you'll have a lot of the greenhouse gases being released back into Earth's environment. Aerosols. Some scientists have found that another influence of the climate change is the aerosol cloud albedo effect. These are from human origins that interact with clouds to reflect sunlight back into space, so the clouds will appear brighter. The aerosols help with cooling the greenhouse gases that warm the surface. And you have sea ice. The climate has shown how the sea ice has melted more with an increased heat flow from the ocean to the atmosphere, and this has shown that clouds and precipitation have been affected by the increased flow. Water vapor is the strongest greenhouse gas. Unlike other greenhouse gases, it is controlled principally by temperature. It has generally increased since at least the 1980s. Precipitation is very variable locally, but it has increased in several large regions of the world, and this was stated by Scientific American in 2008. Here we have a picture of the Arctic sea ice back when it was 1984, and it showed a huge area of where it covered most above where Alaska and Canada meet. Then you have where about 2012, so 7 years ago, you can see that most of this area has shrunk so far where it was going into Canada, now that it's barely even like reaching it. And then this is a picture that shows like how the animals are being affected as well, where their homes are just melting away and they have to kind of hop back and forth to different little ices just to try to make it to one side or the other. Agriculture. Agriculture has some cause of the climate change on Earth. When a field has been altered by machinery, it changes the way that the land will absorb and reflect heat. Some of the plants that have had their environments altered have to learn to adapt to the temperature changes. Agriculture has led to more deforestation and desertifications since the human population has had a slight increase. This has caused more carbon dioxide levels to rise. Since there's less trees for the forests to take in all of our carbon dioxide and release out the oxygen that we need, it's caused carbon dioxide levels from humans just to keep rising because nothing is fighting against it. And then agriculture, you have all of your machinery with farmers, and they use tractors, hay bales, everything else. It causes the land to have to adapt to what is being caused, and everything's just having to fight for its way of living. In conclusion, these climate changes have occurred over small points in time, but they are daily changes that have built up over the last century. This has caused extended periods of more energy in the system. With each passing year, global warming is affecting the Earth by bringing temperatures higher than before. It might be a small change, but more damage has been caused. With future research, hopefully scientists can find more ways of constructing the decrease of greenhouse gases and helping the climate with efficient changes for humans and animals. Hopefully scientists can realize a way to help these greenhouse gases from not only causing the barrier to grow more, but to shorten it and have less of these like toxic gases affecting people and the environment, and helping like more more trees to be grown, so the levels of carbon dioxide can drop, and then less levels of nitrous oxide, and then all the methane in the atmosphere as well can drop too, because it's harming a lot. Even if you don't think about it, it's still like a lot of damage that has been caused to our our planet. And here are all of the works cited pages. And that concludes my project. Thank you.